And onward we go. To the point of this, actually a new friend of mine, Tom Barbalet, is here. He's originally from Australia, now from Silicon Valley, I guess, for the last couple of months. And we're going to see if we can't go 5 minutes or so over, see what happens.
I'll talk very quickly.
Right. I wanted to sort of show you something that he's been working on, and that relates to the different ways of using tools, basically. Whether you use what's there, looking at the evolutionary past of technology through, especially in the way we use graphics, or how you can go back inside and do things in somewhat simpler ways, actually.
I'm not sure if Doug's given you any background with regards to me or whether he's just thrown me in at the end, but I will give a little bit of background. I guess the background of my talk with regards to interface design is what do you do if there isn't actually an interface there? Basically, my background is very much with regards to programming, but also with regards to content as well. In, I guess, 95, 96, I started this thing called the Nirvana Project, which was basically a large-scale simulation environment of a tropical island. And the problem was that I got a public grant in order to continue, but the application looked something like this. It was basically very simple line vectors. Unfortunately, it's running on G3, so as you can see, the simulation component is, it was effectively black and white, no colour, and these little dots represented ape-like creatures that travelled around on the island. There was an ecosystem evolving on the island based on principles in quantum mechanics. But as a kind of visualization tool, let's pause at the best that you could do for something like this. Back then, you've got to appreciate that there were no 3D graphics cards, or what 3D graphics was available wasn't basically available for the end kind of user. And it was really problematic, particularly if you're going to put it into schools or things of this nature, to require them to run silicon graphics boxes or things of this nature. There were models, particularly coming out of University of Houston, to develop virtual reality interfaces at the time for schools, but they all required pretty high-end STI boxes. Funnily enough, you could run it now on an iMac, so things have just gotten progressively faster. I got a relatively small public grant, basically to develop a more 3D environment. And my background is with compilers, with antiviral software. I started programming when I was about 7. I'm still quite active with regards to getting children to program, and when I meet Doug on occasion, I kind of fill him in. I think the issues with regards to programming is not with regards to the whole director versus C idea. It's just the fact that if children start programming at a young age, they can manipulate programming concepts in a way that children can play with plasticine or blocks or things of this nature, and ultimately change the future in a way which really isn't available if you kind of pick up programming in later stages and you're kind of focused in programming models. And I mean, this is even true with people who learn C at university and things of this nature, that basically they're taught it in a course structure, and they've got, other courses that they may be doing, and they can't intertwine it as easily as a child can. So anyway, I got the public grant. I sat in front of a wall for about 3 weeks, and I developed this interface. Again, it's running a little bit quickly, so let's just slow it down. The thing about this interface at the time was I developed it in isolation in Australia. And as I'm sure many of you are familiar with OpenGL and 3D games and things of this nature, fortunately the screen doesn't really do it any justice. But what we have here is smooth surfaces running in real time. In fact, it's running slower than real time. Move it up to real time now to give you some indication of the rendering speed. So basically this is just using optimized mathematics. It's not using any kind of graphics hardware, and it was developed in total isolation in Australia, basically. Let's slow it down a bit again. In about...
so next, the key distinction is that it's not using graphics.
It's not using polygons at all. It's smooth surfaces, basically. And it's using a kind of mathematical skim model, which is very different to the polygonal narrative that we're in even today with regards to billions of polygons. There's nothing analogous to that in this. It's much more a kind of low-level concept. And still not being exploited with graphics hardware. That's some of what I do over in Silicon Valley. Basically, in about 97, Apple, or some of the technicians in Apple, realised that I'd found a way to address the screen faster, so I took on the fastest frame rate, developing in relative isolation back in Australia, and they said I should come over and display this stuff. So I was over here in 98, displaying this to Apple, and they were asking, hairy questions with regards to how I'd actually done it, and I kept relatively mum with regards to a lot of that. However, they said, we've got a narrative here where ATI, I think, was the company that they were using basically to develop their graphics cards, and they couldn't implement new graphics systems. So went back to Australia. I was a sponsored developer at the time while finishing my physics and philosophy degrees. So basically went back to Australia and developed a whole series of other bits and pieces of technology. I put a world map on this for things like airlines, for example. So let's go towards the Himalayas. They were kind of cute. Oh, let's get out of the ocean. Here we go. The main thing, of course, is the speed. You can run this on a Palm Pilot. You can run it even on a colour Game Boy. So when I was in the US in August last year, for example, I went up to Nintendo in Seattle and demonstrated this on a colour Game Boy. So if any of you are familiar with a colour Game Boy, it's really a Z80 based processor, not we're up in Siberia now. Get down to the Himalayas. Anyway, so basically, low-level technology, very low-level technology that is totally against the popular trends developed in isolation. What happened was I was coming through New York, I think in September of last year, and at the time I had an audio compression system which is a similar kind of narrative to this, basically set specifications developed in isolation, and actually, considerably better audio quality and reduction compared to MP3 and things of this nature. So anyway, I was travelling through with that, and Doug said, show the old graphics stuff that you developed, and I had an old CD-ROM, and I think I displayed the world map to you. And then Doug wrote this article without my knowing about it. And it was syndicated pretty heavily. We're yet to try and establish how many papers actually syndicated it, but it was pulled off the wires. And I got about 500,000 hits on the website in about 3 days, and my email was kind of officially flooded for about 2 months afterwards. And then rather than coming back to this part of the world about this time, I came back almost as soon as I got back to Australia. And it's taken off from there. But I think the underlying narrative of interface and programming in C is very important.
I mean, the title of the article is actually "Analog is Better," and the point I was trying to make was that we've abandoned an entire line of graphics and audio evolution, which is developing analog technologies, and instead, we're creating graphics cards that have, now we have the stored sample puffiness, sample steam, sample this, sample that. We need bigger and bigger pieces of hardware and bigger chips in order to run it. Where actually, if you go back and use, I don't know if this would work on an 8088 chip, but
sure.
Would.
Of course, if it'll run on a CD, it'll run on an 8088.
That what we're talking about here is the same. Is really something much closer to the vector graphics of asteroids. Where you're using simple equations to make stuff.
Well, very simple equations here. If you see that you can actually change the island, we're using fundamental Fourier theory basically to change the shape of the island. What I've done in recent months is progressed beyond, let's get it back to just a random walkover, progressed beyond this notion of closed island environments to a global simulation, which takes a far larger data set, but again is runnable on a relatively low-end computer, basically. The idea is, my background, particularly coming, from Australia, is with regards to getting computers that are 5, 10 years out of date, sometimes even 15 years out of date, and making them do what the most modern computers are doing in totally different methods in many ways. So, that was the background with regards to programming and getting older computers basically to do relatively modern concepts.
Right. Obviously the political and business implication is that the forced upgrade cycle of current machines, the rationale has been so that you can do the kinds of whiz-bang graphics that new games and new programs need, when actually it's not true.
Yeah. There's always tricks that can be made. The more people have access to technology, it's always very impressive to see it. Like, I guess the PlayStation is a perfect example. PlayStation games that are coming out now, the exact same hardware that was released several years ago, looks so much better than they did when the PlayStation first came out. Because people figured out tricks and new ways, more efficient ways to use the rendering engine. So there's definitely something to be said. We don't need to keep on upgrading these things if we just know how to use it better. It's a lot cheaper for everyone.
Right. I mean, Intel's putting most of its R&D money now into finding artists and people who can come up with ways to use the P3 chip in such a way that people will want the P3 chip. Because they developed the technology first, and now they're looking for very memory-intensive multimedia applications that possibly require it. And that's, because he was talking about, doing some talks at Intel or maybe working with them, we kind of decided
totally different narrative. It's oil and water, basically. And I kind of, you're relatively, comfortably distanced from Silicon Valley here. But if you ever have the opportunity to actually go into these companies with the perspective of an idealist as I've done, and see the realities that these companies talk about and how distinctly removed it is from what you'd imagine a narrative would be with regards to computer technology, it's actually quite disturbing.
Do you remember when the monkeys walk around?
I do. Oh, like visual, so you can see the monkeys moving?
See.
I didn't really see your arms. I can show photos of the monkeys.
Because the other thing is, all the work he does is based in sort of evolution. So when the islands evolve and the monkeys evolve.
It's the best I can do. I've got rented versions, but yeah, I haven't seen you run with them. Totally unsure of what I'd be actually doing for those. So.
I'm just curious why you specifically choose to travel in the world, I guess? Why is it like
Why is there an implementation of the world?
Representation of the world, our globe.
Well, because the world is a very big map. Okay, so if you imagine, for example, the US Department of Geographical Surveying has a 1.8 gig map of the world down to a kilometre. So it's a big map. The challenge with the world map was basically to compress it very small. So that's what that demonstration did, and to pump it out. Showed that there are applied solutions basically to the technology.
And I was wondering, would it be possible to do something like that to print it? Like, if you decide you want to continue to travel,
Sure. Because basically it's a skin technology, you can apply it to anything. So whether it's a painting or what have you, you can apply it to anything.
What does that mean, it's skin technology?
It means it basically falls flat on the data. So if, for example, it means it literally falls flat on the data. So whatever data you put underneath it will just fall flat on it. But the issue is moving it into 3D, basically, which is the second generation of the technology. Yes?
I'm just wondering, how exactly does it work? Is it like something like there's a wireframe underneath?
No.
It's just the points of the locations. So it's just working in like the.
With the island, for example, if you're talking about the island, it's two mathematical functions which you just multiply together in order to give a two-dimensional map of the island, basically. And with this two-dimensional map, you get other information for free. You get surface area, you get height, and you can apply plants and animals to that information.
And what about the world map? Where does how is the data stored?
Well, the data was originally stored in the GTO 30 format, which is the DEM format, which is basically 1 kilometre squares, each having a height, a Z value, a Z value. So what you then need to do is you need to write an interpolation algorithm that basically takes what's effectively, data that's in 1 kilometre chunks and smooths it out.
So from a landscape point of view, it's just mathematical, like XYZ values?
from a landscape
Not just the
perspective.
landscape.
But from a simulation perspective, it basically takes the underlying elements as well, the deltas and things of this nature, and reconstructs plants and animals from that information as well. But the underlying quantum mechanical notions, yes. That's an interesting question. I did some other earlier work with particle systems, which, yeah, I'd love to have actually brought a wide selection of stuff to display. But yes, I'm supposed to be giving a talk at Caltech that actually deals with quantum atomic systems and things of that nature, where they're not only particle systems, they're also fuzzy particles, basically.
Is some of that on the website?
No. The problem with putting stuff online is that if you put the source code online, I'm slowly updating all the source code. You get emails from people, and it's not much of people knowing how to program. You get emails from people basically asking you to explain everything in a totally different way. And the open source movement actually requires people to maintain it. And I'm not sure of the ratio, but it's a substantial number of people per, how many million lines of code. What I'm moving towards is a more public domain ethos with regards to source code. You can get source code to a lot of this online now through the website. The view there is that on some level you need to be receptive to teaching people how to program. You find a lot of these sites are set up, they won't answer kids' programming questions. When I used to run the site before Doug's article, most of the people who would actually come to the site because they'd be scrolling through the search engine, basically for virtual reality and concepts like this and programming. The people who would get back to me would be 12 to 16-year-olds who basically were starting to program in C or starting to program in BASIC or Logo or even Java and wanting to have some kind of feedback. And there's really no information out there on the web that does that currently. Communication with Wozniak back in Silicon Valley, and a long part of his narrative after he got out of Apple was teaching kids to program, teaching kids to kind of re-explore the computer interface and actually become masters rather than users, basically. I think with regards to pulling apart hardware and it's analogous in software as well. The problem with modern day operating systems is that they're increasingly loony kind of complicated. They're not even complicated in the logical sense. They're complicated in the sense that they can become proprietary, and also in the sense that the companies that maintain it actually make money out of getting coding companies or whatever to come back to them for feedback. So with regards to teaching kids to program on modern day operating systems, it's a kettle of worms, basically. There's a whole lot of steps. The idea is that basically this was a kind of technology incubator which no money came into, and all this kind of technology evolved. So there are things, for example, the audio compression component. There have been lots of spin-off technologies from just this whole idea of the simulation island. And I think that where it goes now is a star-like picture of various bits of technology, plus the Nirvana 2 idea, which is the bringing back all the simulation components, all the public domain components, and dealing with just a much bigger world, basically evolving world, as opposed to just a small enclosed island environment.
What about supporting the network?
Pardon?
Like communication between worlds?
Basically, yeah, we were talking, the previous guest talked about AI theories and things of this nature. Clearly there's a substantial AI component in there as well. Modern AI basically is not, well, a whole series of areas, including VR as well, aren't really progressing in any direction quickly. The idea with having something like this publicly accessible was that basically it would kind of transcend academia with regards to the progression. The communication issues and the world-based issues are things which will evolve in the kind of second generation of the Nirvana project.